On this last lesson about equations, we're going to look at some things what we can do if the equations look complicated, but we also are going to look at some special solutions, as in what happens when all the variables disappear. Do you just stop? No, you don't. So let's look at this problem right here. But we have parentheses, so of course we need to distribute. Distribute here. Then we need to collect like terms on each side of the equal sign. So I'm going to keep the negative 6x, and 3 minus 9 is negative 6. At this point you could just stop and say, hey, that's exactly the same thing on both sides. But let's say you didn't see that and you went, well, my teacher said I need to get the x's on one side, so I'm going to add 6x to both sides. Well, what happens then? I don't have any variables left. The variables have disappeared. You then have to stop and ask yourself, what do you have left? Do you have a true statement or a false statement? Well, negative 6 does equal to negative 6. In fact, if you wanted to go one more step and add 6 to both sides, you would end up with 0 equals to 0, which is also a true statement. That is not the solution. When all the variables are eliminated and you are left with a true statement, then the solution is all real numbers. Again, if you have a true statement, then the solution is all real numbers. What does that mean? It means you can plug in any number you want for x, and it's going to work. How cool is that? All right, let's look at this other case. Okay, again, I'm going to distribute, and I have 8x minus 2 equals 8x plus 12. Well, again, we could get our x's on one side, so if I subtract 8x on both sides, I get negative 2 equals 12. My variables have disappeared one more time, but hey, this negative 2 doesn't equal to 12. That is a false statement. Again, that's not the answer. When all the variables are eliminated and you are left with a false statement, then there is no solution. Meaning that there is no value of x that you can plug in and make that equation true. So one more time, this answer is no solution, and this answer over here is all real numbers. Now, I will tell you a common symbol to use for no solution is a circle with a line through it. That's referred to as the null set. It's also a Greek letter. You can use that symbol. It's not 0. It means no solution. Right? So false is no solution, true is all real numbers. This is an assignment to review everything that we've learned about equations, including these special solutions. So let's just review. We want to distribute, means get rid of our parentheses, and combine like terms on each side. As our last lesson, if we have fractions, we might want to get rid of them with the LCD. Then we want to add or subtract to get the variables on one side and numbers on the other. Then we need to multiply or divide to get the variable by itself, because we want a coefficient of positive 1 in front of x. It could be a different letter, but I like x. And if you have time, you might want to check your answer. Alright, so let's look at number 1. Ooh, I have fractions. So just like on the last lesson, I'm going to look at the denominators. What would be the least common denominator for 2 and 3? Well, the LCD is 6. Now remember, you can always just multiply them together. In this case, 2 times 3 is 6. But always check to see, could you use something smaller? Now, what are we going to do with 6? Well, I have a 1/2. I have a 2/3 times 5x plus 1, and I have a 2. That's really three things. 1, 2, 3 things. And I'm going to multiply all of them by 6. So this is times 6 over 1, this is times 6 over 1, and this is times 6 over 1. Let's be really careful here. 2 goes into 6 3 times, that leaves a 1, so now I have 3 plus. Are you listening? Be careful, don't try to do too many steps at one time. 3 goes into 6 2 times. I'm going to multiply 2 times 2 and get 4, and keep the parentheses just as they are. I repeat, keep the parentheses just as they are. You're going to multiply that together and get the 4, and then the next step we will distribute. Then I have 2 times 6, which is 12. All right, so I have 3 plus 20x plus 4 equals to 12. 20x, add like terms, get the x by itself, so I'm going to subtract 7. I still need that coefficient of 1, so I'm going to divide by 20, and I'm going to reduce my fraction, and that's 1/4. So going back to the very first lesson, you want to keep your equal signs all lined up. This part's kind of new, so we're going to be very careful about that. But 1/4 is our answer. All right, let's look at the second one. Yay, no fractions. So let's just distribute. Keep the 7, distribute that. You don't add 7 plus 6 and get 13. Order of operations, we've got to multiply the 6 times the parentheses and then put the plus 7. Be careful. All right, so collecting like terms on each side, 2 minus 24 is negative 22. 7 minus 6 is a positive 1. And at this point you should see, hey, I've got 12x and 12x, and so if I subtract 12x from both sides, all my variables go away. That's why you should do those before you do your constants, for this very reason. Now, all the variables disappeared. I have a false statement. So what does that mean? No solution. And again, you can say no solution, or you can write the symbol for that, which would be that null set. Also, in some textbooks, you'll see just empty braces. That means the set of nothing. That means there's nothing that works for x. Oh wow, man, fractions. So now again, you could distribute and make them all the same denominator and all of that, but man, that's just hard, I think. So I think this is an easier way. Let's look and see what is the LCD for 2, 4, and 8. Well, if you don't want to multiply all that together, you get like 64. Way too big. Okay. How about 8? Right? 8's going to be the smallest number that they all divide into. Okay? The LCD cannot be any smaller than the biggest number you're looking at. Okay? So if you said 2, that's too small. Least common denominator, 8. So I have this, 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 and this. I have 4 things that I need to multiply times 8. So I'm just going to take some time and rewrite this so I have a little more room. Going to space everything out. So I'm going to multiply this times 8 over 1, 8 over 1, 8 over 1, 8 over 1. And remember, the idea is to get rid of my fractions. So when I divide, when I'm reducing these fractions, all the denominators go to 1. So 8 goes into 8 one time, 2 goes into 8 4 times, 8 goes into 8 one time, 4 goes into 8 2 times. And I have all 1s left in the denominator. Okay, so I'm going to multiply that together, so that's 5. Keep the parenthesis exactly the same. minus 4. Keep the parenthesis exactly the same. That is 1x plus 2 times 3 is 6. Now we're going to distribute. Remember, we're going to distribute a negative 4. Oops, I don't know why I put that equal sign. Okay, so I have minus 4x plus 20. Going to collect like terms. So that's 6x. Ooh, what's 20 minus 20? Or negative 20 plus 20? That's 0. Now I'm going to put my x's on one side. I think I'll take them over here. So I have 5x equals 6. Divide by 5. And I get 6/5. Go over that problem one more time. Do it a little bit slower. Think about that LCD. All right, no fractions, but we have all those brackets. Remember that from the very first lesson? We want to work inside here first. Get that all prettied up before you distribute that 3. Okay, so I'm going to keep the 3, and then I'm going to distribute. Going to distribute that negative 2. Now at this point you could distribute the 3, but that's really not the best course of action. Again, we're not done with that. Let's collect like terms inside. So I have 6 minus 2x and 2 minus 8. Now distribute the 3. And at this point you could say, hey, those are the same on both sides. That's a true statement. I know what the answer is. But just in case you didn't, you could keep going and say, well, I'm going to move my x's. And then you could say, oops, those all canceled out. And when your variables disappear, you want to say, do you have a true statement or a false statement? This is true. Don't stop there. That's not the answer. The answer is all real numbers. Again, meaning you can choose anything for x and make that equation be true. So go back through these steps, make sure you know all of those about the LCD, the fractions, and those special solutions.